Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, how are you today? Today we will learn about matrix with the subchapter is transpose of matrix by me, by Miss Rara. Without further ado, so what is transpose of matrix? Transpose of a matrix. The transpose of a matrix is formed by writing its column as a rows or row as column and denoted by a power t or axn. But in here we make the symbol a power t for we are using letter. So from here we know that if the matrix A have a dimension is m by n, because we want to transpose that matrix, the dimension, the first in the beginning, they are the first m by n, but when they are after the transpose, the dimension the change to be n by m. So from here, we can see if the beginning, the dimension is m by n, but right now, the transpose for the matrix A, the dimension changes to be n by m. So from here, we have the property of the matrix transposition. Okay, the first, if A and B are two matrices, that can be added then. So which is if they want to be added, you need to make they have the same dimension, right? So when we want to transpose the both of them, it's also equal with the A power T plus B power T also. And then the second, for any matrix, if you find the matrix, it's already transposed, and then you transpose again, they will back to their self is the A matrix. And then for any matrix and any real number, or this is, we can say matrix by scalar, C times A power T is that the meaning C times A power T. So from here, we know that if the constanta doesn't have any transpose, because that constanta doesn't have include with the matrix, constant is this constant, right? Okay, if A and B are two matrices that can be multiplied, then remember, if we multiply A, B, and then we get the result, will be transposed, and then the transpose will be changed to be B power T times A power T. So from number 1 and then the number 2, you can see that the difference. If they have the addition for the two matrix, they will be transposed with their self is A power T plus B power T. But if they have the multiply matrix, when they want to be transposed, they will be changed the position to be B power T times A power T. So how about number 5? Number 5 is the same with the number 1. Remember, if they have this addition, A plus B plus C, close bracket with the power T, the result will be the same, A power T plus B power T plus C power T. How about the 6? The 6 is the same with the number 4. A times B times C power T is that the meaning C power T times B power T times A power T. So guys, without further ado, so let's jump to the example. Example of transpose matrix. Let A equal minus 5, 7, 1, and 3, 6, minus 2 with their dimension is 2 by 3. Then you need to find the A power T. So we know that, we already know from the definition, if they first with the m by n, so the dimension for the A power T is n by m, which is A power T to be 3 by 2, right? So from here, we have the definition. You can change between a row as column, or you want using a column as row, everyone. So from here, if you are curious about the first or the second way, it doesn't matter. So I will using first for the row as a column. So we have the A to be T. I'm using the number 1, yeah. So this one, they have the dimension will be have 3 by 2. So the row change to be column. Row is the position horizontal. And then we want to change to be, yes, vertical. So this one is to be minus 5, 7, and 1. And then the second row to be second column, 3, 6, minus 2. So this one is 3 by 2. We are using row as column. But if you want to using the number 2 column as a row, we can write to be a power t. It's also equal with the. So from here you can see they have the column. Column is minus 3 minus 5 3. So this is a vertical. We want to change to be horizontal. So this one is to be minus 5 3. 7, 6, 1, minus 2. So they are also have the same dimension. So this one is column as row. So everyone, I hope you understand what I'm explaining. So next we will have another question, another example I mean. Given the A equal cosine theta, sinus theta, minus sinus theta, cosine theta, you need to find the A times A transpose. First thing first, you need to do with the A transpose. Remember, this is the dimension with the 2 by 2, right? So the transpose, it will have the same dimension, right? Because they are square matrix. So from here, we want to change the position row to be column. So this one is to be cosine theta to be sine theta, and then the second row to be minus sinus theta to be cosine theta. So from here we need times with the A. A times A power t, it's also with the result cosine theta sinus theta minus sinus theta cosine theta times by with the A power t is cosine theta minus sinus theta cosine theta. So let me change the thickness of this line to be 1. Okay, so from here, remember that you need to times between the row and then the column. Cosine plus cosine is cosine square theta plus sinus time with the sinus to be sinus square theta. Okay, this result will be have dimension 2 by 2 because the first they are starting with the dimension 2 by 2. And then the first row times with the second column is to be minus cosine theta sinus theta plus sinus theta times cosine theta. And then after that, we times the second row with the first column. This one is to be minus sinus theta times cosine theta plus cosine theta times sinus theta. For now, the second row and then the second column. The second row to be sinus square theta plus cosine square theta. So from here, we know that this one from the identity of trigonometry, this result will be 1. This one is to be 0. This one is to be 0. This is to be 1. So A times A power theta, it's also equal with the identity. So I hope you understand. So let's jump to another example. If A equal x plus y, x minus y, and then B 1 minus a half x minus 2y, 3, and A power t is equal B, you need to find x plus 2y. So from here, we know that this dimension is 2 by 2 is also equal 2 by 2. So the A transpose will have the result 2 by 2, right? So A transpose is equal, we want to change from the row to column or horizontal to vertical. So x plus y x and then y x minus y. So they told us if A transpose is equal with the B, it's to be 1 minus half x minus 2y, it's equal 3. Okay. So from here, we want to find the, okay, from here we have, if we have that for the A11, it's equal with the B11 is x plus y, it's also equal with the 1. And then x minus y, it's equal with the 3. So we will just solve this one to be 2y is equal with the minus 2. So the y is equal to minus 1. Is y minus 1, x minus 1, I will to substitute to here, is equal 1, so x equal 2. So let us prove that. This one told us x equal minus 2y. X equal minus 2y. So we have the x is 2, right? And then minus 2y, so the y is equal minus 1. So this is proven, right? So we want to find the let me change the color to be x plus 2y. So we have the x is equal to, and then we have the y is equal minus 1. So 2 minus 1, 2 is 0. So guys, so if you want, just choose the, not the all of the matrix, it doesn't matter. As long as you can compare what the easier equal equation for you to solve this problem. I hope you understand. So now let's jump to another example. Given P of P is equal minus 2, 1, 3, 4, 2, minus 1, and then the key is minus 5, 2, minus 3, 2, minus 3, 1, you need to find the P times key power T. So from here, we know that if the P have the dimension 2 by 2, and then the key have dimension, oh sorry, not 2 by 2, but 2 by 3, and then the key dimension 2 by 3, and then we need to find what the key transpose. Key transpose, because 2 by 3, the dimension to be 3 by 2. So from here, we want to transpose from the row to the column. The reason why I took the row to column is make it simple. Because if we doing some column by to row, it's to take so long for me. But it doesn't matter if you like to column to row. So from here, we have that the key transpose is minus 5, 2, 2, minus 3, 1. And then we need to we need to multiply between P times key transpose. P key transpose is equal with the minus 2, 1, 3, 4, 2, minus 1. You need to times between the minus 5, 2, 2, minus 3, 1. Remember that before you try to answer this, please find their dimension first, because this is multiple, I mean. So for this is 2 by 3, and then this one is, how many row they have? 3, and then they have 2 column, 3 by 2. So this is equal 3 and 3. So the result will be like half the dimension is 2 by 2. Okay, so from here, let me change the color. So from here, we need to solve this one. Remember, for the multiply, you need to times between row and then column. So minus 2 times minus 5 plus 1 times 2 plus 3 times minus 3, and then the row and then the second column, minus 2 times 2 plus 1 times minus 3 plus 3 times 1, okay? And then the second row with the first column, 4 times minus 5 plus 2 times 2 plus minus 1 times minus 3. And then the second row times with the second column, 4 times 2 plus 2 times minus 3 plus minus 1 times 1. Okay, so the result will be 10 plus 2, 12. 12 minus 9, 3, right? Okay. Minus 4, minus 3, 7. This one is minus 4. Minus 20. Minus 20 plus 7, minus 13. And then 8 minus 6, 2. Minus 1, 1, right? Let me check. 10, 12. Oh, sorry. This is 12, right? 12 minus 9. 3 is correct. And then this one minus, yeah, okay. This one minus 4, minus 20. Minus 20, this one is just 7. Minus 20 plus 7 minus 13. 8 minus 6. 8 minus 6, 6. 2. 2 minus 1, 1. Okay, this is correct. So I hope you understand what I'm explaining today. So guys, please do your task number 4. I hope you understand what I'm explaining. So everyone, so thank you for today. I hope you more learn about the transpose. So I hope you understand what I'm explaining today. Please do your task. If you doesn't understand what I'm explaining, please comment in my YouTube below. So guys, thank you. Assalamualaikum warahmatullahi wabarakatuh.